In the last session, we already completed most of our functional parts of our code, including modules for weather, Wi-Fi, and button control. Now we're moving into the final part, flashing the program and handling the main program logic. This section is broken down into 3 parts: program initialization, main loop logic, flashing, and testing. Let's jump straight into the VS Code. Now we will continue and finish things like startup animation, font settings, and Wi-Fi status check. Startup animation is basically showing the logo when the device powers on. Just to give it a more polished format feel, you can center it on the screen and show it for a few seconds. The duration is up to you, it could be 5 seconds, 2 seconds, however long you want the animation to last. After the animation, we'll set the default font, initialize Wi-Fi, and start listening for router connections. Then we'll check whether the Wi-Fi is connected. If it is, start the time sync service and pull the current time from an NTP server. Next, we move to the next screen where we display the hotspot IP address on the screen, something like 192.168.4.1. This IP is fixed. Whether or not the device is connected to the internet, as long as your phone or computer connects to the local hotspot, you can use that IP to access the control console. If you want to change a hotspot name or password, we've left the spot in the code for that. You can go in and change it directly. Now if the screen looks weird during all this, don't forget to double check the screen driver. For example, the screen we're using this time is 128 by 64, so make sure the driver matches the resolution. Alright, with that done, we'll finish the setup part of the code. Now let's move into the main loop, which is the loop function. Inside the loop, we mainly handle 3 kinds of logic: emoji state switching, free mode logic, movement control logic. If the current emoji state is different from the last one, we'll clear up the screen, update the display, and sync the current state. In free mode, we change the action state every 3 seconds. The street value is generated randomly like a number between 0 and 9. For motion control, we use the switch statement to check the current action state. If it's 0, we do nothing. If it's 1, we run the move forward function. 2 is turn left. 3 is turn right. 4 is trigger back leg action. 6, lift the right front leg. 7 for lying down. 8 is for sitting, and 9 is for sleeping mode. 10 randomly switches to a new emoji. Every time when the action is completed, don't forget to reset action state back to 0 and wait for the next trigger. Next, let's handle the screen display logic. Here is 2. We use a switch to check the current emoji status and display the corresponding icon. 0 is high, 1 is energy, 2 is 0, 3 is wet, 4 is low, 5 is 6, and 6 is P, could be your custom icon. 7 is a weather icon, and 8 is a time icon. Including each case, we create a page and use UAG2.nextPage to show the image. Now if the status is 7 weather, if Wi-Fi is disconnected, show a need net message. If Wi-Fi is connected, call the weather function we wrote earlier and display the current weather. And if the status is 8 time display, if not connected to Wi-Fi, show a connect message. If connected, then display the current time. Make sure you call the NTP sync function at least once to get the latest time info. We're using an icon to represent the clock, so if you want to look more like a traditional clock face, like with hands rotating, you will need to modify the code for that kind of display. But to keep things simple here, we're just using an icon. Now after syncing the time, we need to create 2 variables. One for the hour, we get that from time.second.getHours, and one for the minute, defined using time.second.getMinutes. So now we have the hour and minute. How do we make it look like a proper time format, like 12:30 in a corner? We need to add a column between them, but these are int types, so how do we combine them with a column? Simple. We use string to convert the number to strings and consonate them. We define a variable called nowTime, which means current time, then we convert the hour to a string, add a column, and then add minutes as another string. Once that's done, we display it on the screen. Before that, we can create a title with a function that adds time in all caps, then display the time. You might wonder, why not just use the previous function just to display the time? Well, if you hover that on function, you'll see that the char type, but we're using string here. So what do? No problem, just use UAG2 to set the cursor position like 64 and 50. Why that position? You can experiment with different values to see where it appears on screen. Then use print to print nowTime. Why use print? If you check the function definition and you add a string, So print works, not str. At this point, the time display page should be working. We're still missing one more page, the logo page. You can just copy the code from earlier and change the text to logo. Now, if you look at our emoji IDs, they go from 0 to 6. So when we do random emoji switching, we also limit it to 0 to 6. And with that, the whole code is complete. Now let's just talk about the flashing steps. You have to follow these exactly, especially the jumper setting part is crucial. Recommend soldering up the robot hardware first, then dealing with the software. Before flashing, connect the jumper between IO0 and GND, then power on the board. That order is very important, don't reverse it. For power, if you're using a USB flasher, you can only supply 3.3 volt, but the robot system might need 5 volt. That's where the battery as the LDO power module come in. It provides the extra power. The USB flasher alone cannot run the whole system. When winning the serial connection, remember that TX and RX need to be crossed. So flasher TX go to your board RX and flasher RX go to your board TX. This is a super common mistake, don't wire TX to TX. In VS Code, look at the bottom left, check mark is compile, arrow is upload. Compile first, make sure there's no errors, then click upload. If it just keeps and loading doesn't enter flashing mode, probably means the serial connection failed. Check the wires or jumper cap. During a normal flash, you'll see the LED on your ESP8266 blink. It blinks every time a byte is written. After flashing the program, don't forget to upload the file system. This is for the web files. If you skip this, your browser will say file not found when you try to access the dashboard. So how do you upload it? First, unplug the power, then remove the jumper. Plug the power back in, the robot should boot normally now. Once it books, unplug it again, reattach the jumper and plug it back in. Now it's back into flashing mode. Platform IO, go to the left sidebar and click the icon. Find build file system image, this is built into the file system. Click to compile it, check the output. It's compile and bundle your 3 HTML files into the firmware. Next, click upload file system image to upload it. You'll see the ESP8266 LED blink again during the upload. How you can remove the flasher and jumper and power the board using the battery. After the startup, the robot should the startup animation go into the Wi-Fi config screen and respond to button controls like forward and backward. If you've set up servo auto reset, it should also return to default posture after startup. If everything runs smoothly, that means you successfully complete the full software and hardware integration. Alright, that's it for the lesson. Thank you.